Greetings and welcome to another installment of Quant Slob. This is 8 in our foundational series, and this time around part 2 of our 3-part micro series on terminology and symbols. Our focus here is going to be on mathematical symbolic representation. Mathematics is the language of science, and science is the foundation of technology. If we are a stranger to math, we may end up being a bystander to technology. The key to begin to understand math is to recognize something that we already know, and that is that math uses symbols to express things. The things that math expresses with symbols are highly varied and range from variables to functions to rules or operators. Of course, using symbols to refer to things is not new to us. We may not think of it, but simple conversation, written and spoken word, is highly and entirely symbolic. In fact, while mathematical symbology has only been widespread for, say, 300 or so years, modern mathematical symbology has roots likely as an extension of regular common language going back thousands of years. So what's the deal? Why do mathematicians so universally use symbols? Well, the best answer for our purposes is simple. Using symbols makes mathematical statements much more compact, concise, generalizable, and even, as a surprise to some, much more readable. So let's consider an example. Consider the following statement. The area of a rectangle is equal to the length of its width multiplied by the length of its height. This is a mathematical equality expressed in common language. By the way, this is known as a so-called rhetorical expression. Using modern mathematical notation, we can state this rhetorical expression like so. Ultimately, the two statements, the expository statement and the mathematical statement, are equivalent. There's something important we need to recognize here, though. This particular equation is very commonplace. It's used by carpenters, designers, painters, engineers, just to name a few. And so for many people, A equals W dot H will be quite familiar. But for someone unfamiliar with this equation, the meanings of these placeholders, A, W, and H, might be mysterious. The equation by itself may be insufficient to be appreciated by a broad audience. So modern mathematics, of course, uses common language combined with symbols to make statements more explicit. For example, we can offer something like this right here. Just like anything else, we need to provide context for clarity. What's really nice here is that these value placeholders, W, H, and A, can be repurposed to provide equalities for other geometric objects. And even here, I think it's easy to imagine how much more direct these representations would be than if we attempted to use common language or a rhetorical expression. Area equals width times height is a mathematical statement. It is also, of course, an equation. In particular, it's also an equality. The equation is general in the sense that it is true for any rectangle. At some point in one's education in mathematics, we lose the time symbol, the cross there, and multiplication operation is denoted by a dot and then ultimately by the absence of a symbol. Multiplication, like addition, is commutative, meaning that the operands can be swapped or transposed. And I don't think this is going to impress anybody, but I think it's kind of interesting. Because multiplication is commutative, then so too are the entities that they represent. In other words, as far as computing the area goes, it makes no difference how we label the dimensions of our rectangle. That's going to do it this time around. Thank you so very much for tuning in. I really do appreciate it. And don't forget to stay tuned for more Quant Slob.